My topic is on ferroelectric source and their application to diesel power production. The use of the ferroelectric materials as electron emit was proposed many years ago by Miller and others, and their particular application as electron source was first reported by Wendell in 1989. The principal pursued power application envisaged for these emitters emits as cathode in the electron guns for use in high power microwave experiments. The electric cathode has a number of advantages over field emission source as they are extremely switchable and can produce high current density beam illuminating or at least reducing the need for subterranean beam compression. Their application will low long life. High repetition rate source is really critical depends on whether the emission is solely a result of the results of the free charge on the ferroelectric surface or if due to plasma formation in the currents. A discussing of this process will form a major part of the following presentation. Second major pulsar power application studies is their use as reliable in switches. After issued October 14, 1996 to February 24, these works were supported by an advance. The work of Asian National was supported in part by U.S. Department of Energy. CB Philadelphia with the Department of Electric and the Computers. Results have been reported with ferroelectric cathode, where current density of up to few hundred amperes per square centimeter have been achieved, with pulse duration of several microseconds. A shorter duration pulse and the cathode radiation rates of 2 MHz have been achieved. Focus on the result report in the literature and include a brief account of the physical interpretation of the possible use of ferroelectric source for application is indicated. Ferroelectric materials. Ferroelectric material can be defined as dielectric material in which polymerization remains permanently even after removing the application electric field. Moreover, the direction of the dipole moment can be switched by application electric field. Among the 32 crystal classes, 21 have non-centrosymmetric and 20 have direct piezoelectricity from the which form polarization through mechanical stress. 10 of the piezoelectric crystal class have spontaneous electric polarization, and their electric polarization varies with the temperature change, which is called bioelectricity. Some of the bioelectric material are ferroelectric material whose polarization can be reserved by external electric field. Before ferroelectric material have both the ferroelectricity and piezoelectricity relationship are issued in a vegan diagram. This is the diagram. Ferroelectric materials. This material have ferrovistic structure like BaTiO3, whose general chemical formula is AbO3, where A and B are atoms are catones. Normally, a cathode has a radiation of 1.2 to 1.6, and the cathode have of the 0.6 to 0.7 associated. The cube corner and oxygen atoms are associated of the phase center form ilmenite ferroelectric material. The ilmenite ferroelectric material have the same chemical formula as ferroelectric material. However, the cathode is too small to fill the position of the ferroelectric crystal. Coordinated oxygen atom comprise hexagon close packed layer. A and B atoms are positioned at the octahedral side between the layers. Polymer ferroelectric materials was discovered and the most respectively polymer ferroelectric material is polyvinylidene fluoride (PVF). Polymer have a long carbon backbone, so this structure is complex and have a lot of configuration depending on whether the neighboring carbon bond are trans among the configuration of PVDF or ring configuration. Fluorine atoms have the strongest electronegativity resulting C and F polar bond so that PVDF molecule has diploma moment. Basic fields of ferroelectric material and the electric emission. This section, the basics is electric material and how their material can be used for the electro emission will be present. This is followed by expansion of technology for producing ferroelectric material and their preparation for field induced electric emission will be presented also electro emission have been observed. The applied magnetic field is removed. There is a magnetic magnetization which lead to macroscopic magnetic properties of the materials. Ferroelectric materials such as barium titanate, lithium niobate, triglyceride sulfide, and the lanthanum different titans. Exhibit analysis behavior with the expansion that has the hydration of bulk samples of PLFT and prepared by conventional ceremony fabrication methods. With this innovation was the leading and maximum forward of the construct material. The forward are part presented into the upward shape and they shifted at a high temperature in atmosphere to form a bulk sample. These materials they may be polished and the grade applied. Emission from F ferroelectric material. Receive certain experiment out of the generation of the electrode from the ferroelectric electric medium. They are rapidly switched around in the minor axis. Several books have been reported on the emission categories characteristics. The threshold field from emission progress is thick than 1 mm. The sample is reported to be about 10 kV centimeter. Also, to thinner samples, the threshold appears to increase somewhat. The highest field report of 100 in most cases, following the original work of grounded front surface regular with a in this section, we focus on providing a discussion of important aspects of the emission process for the application of ferroelectric source to fluid powered device. Almost all the features required to demonstrate the principle of ferroelectric cathode to pulsed power needs have been met, albeit not simultaneously nor in the same material. For example, the repetition rate capacity at pulse repetition rate of up to the possibility of using externally is thin sample of this material for electro emission very intense due to the very low application voltage that will be required for thin as well as the possibility that emit will be deposit on unique shaped cathode. Also, the only thin by the sun. The property of these two systems of material will be expected to be somewhat different due to the difference in gravity. Conclusion. Although experiment research into the phenomenon of ferroelectric material have been performed by many groups worldwide, the nature of the experiment mechanism by which emission take place in the still unclear. The studying of the future complicated by the variety of materials, stoichiometric used, and the wide difference in experiment. Thank you for watching my video. Please like, share, subscribe.